Hi, everyone. Thank you for joining today's ELISA seminar or webinar. Today we're very delighted to have Thomas Aynaud, who is the CTO for Software Heritage, to give us a talk on Software Hash ID. You will not be able to live without it. With that, I'm going to pass the microphone to Thomas.
Hi, thank you for the introduction. And yes, I'm Thomas. I will speak to you about Software Hash ID or SWHID, and maybe it's a bit too an advertisement. You may be able to live without it, but it's still an interesting technology. So let's start. I will the agenda today. I will tell you a few words about the software heritage by itself, because it's important to understand what are the SWHID and where they are coming from. Then I will speak also briefly about SWHID, what they are, how can you compute them, what is interesting with the SWHID. Then I will go to what are the SWHID today and how they become independent from the software heritage itself. And they are a new organization, in fact, and a new ISO standard. And then I will briefly go to some usage that you can do today of the SWHID and some usage that you may expect from the SWHID after that. So let's start with the Software Heritage. So Software Heritage is an organization, a non-profit organization hosted by the UNRIA, and our goal is to build the library of Alexandria of software source code. Our mission is to collect, to preserve, and to share all the software that is publicly available in source code form. We do that because we believe it's important. There are a lot of knowledge inside the source code and a lot of human knowledge, and we do not want that we lose this knowledge. And we want this knowledge to be available to a lot of people. So the Software Heritage by itself is a non-profit organization. It was started at INRIA 10 years ago. INRIA is a French governmental organization doing research about computer science, but it's backed also by many other organizations. You have organizations from the public sector, mostly in Europe or in France. You have some academic organization which supports software heritage, French governmental research organization, but international also. You have industry supporting the software heritage, giving us some money to do the archiving or helping us with different projects. So basically, we see the software heritage as the largest archive ever built of source code, obviously. And we do that for different pillars. For instance, for cultural heritage, we want to conserve everything with the software heritage about the source code, but we want it to make it accessible, for instance, for industry or people who want to use this archive to build some cool application. For research, we see ourselves as an observatory of the source code, for instance, where you can do a lot of analysis on how people will build software, on how the software is built by itself, and for public administration to be able to store reliably some source code. Today, we have a lot of source files archived in fact, today is 26 billion, and we store a lot of things. And it's one infrastructure that is open and shared with everyone because it's more efficient to have one infrastructure and to open it to everyone. So the data we collect. At first, we collect the source code files. Today, we have 26 billion deduplicated source files archived inside the software heritage. But we also archive the history of the development. We have 5 billion of code revisions with the date, a message, the author of the revision, some related files about the revision, and so on. And we also store metadata from the code itself, like the code meta vocabulary, where you can put some information about your project inside your project, or from the ecosystem around. For instance, you have a lot of metadata if you are a GitHub repository, and but we tend to be agnostic to the forge, so we try to do that not only for GitHub. We also store the release, some specific version that have been tagged by the developers on package information, and so on and so on. We collect that from a lot of different origins. The biggest one is obviously GitHub, where you have a lot of source code, but we can also grab source code from GitLab, from GOGS, from SourceForge, from Fabricator, from almost everything that you can imagine, where there are source code, and some of them do not exist anymore. For instance, GitOUse or Google Code or Bitbucket Mercurial has been discontinued, and we have the source code that were hosted on those platforms with the development history. How do we do that? We have several bots that are crawling software forges and translating it to our data model. So we have several services which will connect to those forge, list all the repository that are inside it, and then come to each one to grab the code, grab the history, convert it to our data model, and store all the file to the archive. Another way to archive for us is what we call the deposit. It's an API mostly used by libraries advocating for open science. For instance, HAL, Intrinsic, Zenodo, eLife, or IPOL. It's mostly academic here. And they send us the code, we archive them, and we give them back a SWHID so that they can identify very precisely the code that they want to connect or link to a research article. Another process to archive is the swap, the software heritage acquisition process, mostly for older historical source code. Think about the code that you may have on a floppy disk inside your garage and that you want to share with everyone and that you want to conserve even after you may disappear. And we do that with some technical gems, some very important technology for us. So the first one is our object storage to store all those source files, the 26 billion, and it represents 1.5 petabytes of data. And we have to store that. And it's kind of complicated because it's a lot of files, and mostly object storage are focused on a big file, but we have 26 billion of files around 1 kilobyte. We also have a graph compression algorithm internally, which make us able to access to the whole code history from one server and to make requests on that. So we can compress all this history and access it from one server to say, okay, tell me the history of this particular repository from this point to this point, and so on. And finally, we have the SWHID, the Software Hash Identifier, which I will speak more about that right now. If you want to browse the archive content, do not hesitate to go to archive.softwareheritage.org. And if you want to see the code, because everything that we do is open source, we believe that it's really important because we are building commons to share the source code, and it's important for the archiving process that you get access to the code used for the archiving. So, in a nutshell, we have several bots, lister, which will connect to all the forges, all different kind of forges, make a big list of what we call the software origins. Then we have service called the loaders, which will go to all these origins, get the code and the history, and put that inside the object storage for the storage and long-term storage of the source code file, and to what we call the graph to keep the history. So we have the global development history permanently archived in a uniform data model, even if it's SVN or CVS or Git, it's in the same data model inside the software heritage. And we have one infrastructure which is shared, it's more efficient, less waste, and it's a universal knowledge base about software and software compliance. No, I will speak more about the SWHID. So SWHID, it's an acronym for Software Hash Persistent Identifier. At first, it was connected a lot to the software heritage data model. If you see the graph, you have different type of object inside the graph. So you have the content, CNT, but you have also directory, revision, release, and snapshot. If you look at how a SWHID is described, it starts by SWH, it's the prefix, it's a common prefix, it's everywhere. Then a schema version, 1 for the moment. We are working on thinking about a version 2, but for now, everything is in version 1. Then you have the object type, if it's a content, a file, a directory, something containing other directory or content, a revision, something a modification done by someone on the code linked to a directory, a release which target a specific revision, and the more internal to the software heritage, the snapshot which describe a moment where our crawler goes to the origin. To this identifier, you can add a lot of context. For instance, you can put some origin context to describe, okay, I want to see this specific object, the object 41DDB, but in the context of the origin of the Apollo source code, for instance, because this file can be in different repository, and I want to see it in this context. I want to see it in the context of this visit, of this revision, of this path, and I can add also context about the line that I want to see. One important feature is that it's intrinsic. You can compute the SWHID if you have the object. If you have the object, you can compute the SWHID. You do not have to rely on anyone to compute the SWHID. It's decentralized because you can compute it on your own laptop if you want, if you have the code. And those are cryptographically strong identifier. It's a SWHID. So what you can represent with a SWHID, it depends on the granularity. You can represent at first some code fragments, contents of the file on given file. You can represent, okay, get an identifier, an intrinsic identifier about a file, about a directory, about commits or revision, about release, or about snapshot, which are mostly internal to the software heritage. You can use some other identifier for other version, but they are not intrinsic, they are extrinsic. Someone is telling, okay, this is the release number X, and you cannot compute, and you have no guarantee that it will exist at the long term. So the SWHID, how to compute a SWHID. We store everything that we have inside the software heritage in what we call the Merkle directed acyclic graph. It's a kind of blockchain, if you like some buzzword, but we do not do that to earn a lot of money. We do that because it's interesting as a data structure to represent that. So if you want to compute the SWHID of a content, basically it's just an hash of the content, the SHA-1 hash of the content that you can compute given the content. Then a directory, it will be an hash, a SHA-1 hash of all the SWHID of contents inside the directory or directory inside. So the SWHID of a directory will depend on the content of the directory. A revision will be the hash of the main directory, the previous revision, and revision data. So if you change a revision before that, it will change the SWHID of your new revision. You have a very strong identifier that everything is connected to it and before that. And then you have the release. It will be a hash of the release data and the revision inside the release. So why SWHID are intrinsic? Because it's more easily computable on local files. It's decentralized. You can compute this at scale. You can compute it on 26 billion files if you are crazy like us, but you can compute that on your own code if you want, or even private code. It's decentralized. There is no central authority. No one is selling you SWHID. You can already compute some SWHID from your own code if you want. And it's applicable to your code, even private, because it's decentralized and intrinsic, and it has some strong integrity guarantee for you, because if you modify the file, it will modify the SWHID by itself. If you modify the file inside the directory, it will modify the SWHID of the directory. If you modify something in a revision or before the revision, it will modify its SWHID. So you have a lot of guarantee that everything of the integrity of your file. So the SWHID identifiers enable you for precise references in regularity documents. If you put a SWHID of your file, it's the most precise references about your file that you can get, I think. It's stable on tamper-evident identifiers for software artifact in compliance, audits, and SBOMs. You cannot modify a file without modifying its SWHID. So if you represent it by a SWHID, you are representing a specific version of the file, not modified. It's also cross-platform because it does not depend on what you use for hosting or to store your repository or your naming conventions. It can be applied on Git repository, on Mercurial repository, on a big monorepo if your team is working like that, on several repositories if you want. It's tooling independent and it's now normalized. So it brings me to the SWHID today. As I mentioned, as I explained it, SWHID was tightly coupled at the beginning with the data model inside the software heritage. It was think from the data model of the software heritage, which look a lot like the Git data model with different naming to be agnostic. But now the SWHID is becoming independent from the software heritage. So it has become an ISO standard, and SWHID is no longer owned by the software heritage. We have built an open and transparent and collaborative and vendor-neutral governance about the SWHID. SWHID is open to everyone. We are as transparent and collaborative as possible about this standard. It became an ISO standard this year on April, and we defined a governance for this standard. So to continue about the governance of the SWHID, we have bylaws. It's detailed in the governance document. Our idea is that we will make some decision-making based on consensus, and it's an open process to produce an improved specification. We have defined a license for the specification itself. It's a community specification license, or for contributions, we ask them to sign off with GitHub a specific CLA. We have built a GitHub organization dedicated to the SWHID and a mailing list dedicated to the SWHID. And the core team is responsible for governing the SWHID project. Is divided in two kind of people: the maintainers, who are scheduling and leading the meetings, reporting and educating new participants, and we have the editors, who will ensure that the contents of the specification produced by the different working groups are complete, coherent, and adhere to applicable formatting and content guideline. So we have an open, transparent governance of the SWHID. It's not anymore a project only backed by software heritage. So we can see some usages of the SWHID. Of course, it's still a bit connected to the software heritage, but if you have a SWHID, you are backed by the software heritage. Software heritage already archived 26 billion of source files for millions of origins. We have many mirrors of the software heritage. For instance, we have a mirrors in France. It's the main archive, but we have a copy of the archive in different cloud provider, in Amazon or Azure, for instance, and we have copy of the archive at different universities also in Europe, one in Greece, one in Italy, and soon one in Germany. So it's built for reliability. And if the code is available at the software heritage, it can act as a kind of backup of your code. Okay, today you know that you are relying on this specific repository on GitHub, but at some point it may disappear. If you have the SWHID, you can still come back to the software heritage and get the code. With the software heritage, you get some features also. We can help to, for instance, for provenance, to find the origins of a specific source code. Another functionality that you can do with the SWHID and with the graph on the software heritage is what we call the scanner. And it answers the question, does the software heritage know my code? So the scanner is an open source and open data code scanner that you can run on your code. So you will run the scanner on your repository, on your code, on code that you have access to. It may not even be yours. It will compute the SWHID of each files and directory of this specific repository. Then it will ask to the software heritage, do you know this those piece of code? And with the graph, it can be really efficient, and you get really efficiently an answer about everything inside the repository, which is known or not by the software heritage, and you get a web UI or a dataset about your code. So the design is that the software heritage archive act as a source of truth about the public code. The graph and SWHID are here for maximum scanning efficiency. You get file-level granularity, and the output is a source-free partition into no or no unknown file from the software heritage. It looks a bit like that, the output of the scanner. I run the scanner on a personal repository. It's something which is open source, but I alter it with a malicious file. So I get a dashboard, a result summary, that the scanner asks to the software heritage, that almost everything inside the repository is known, 96% of the file. It's a small repository, so only one file is unknown, and some information about how I call the scanner. After that, I can go and browse the result tree. I see that many files are known by the software heritage. So the dev container directory is known, Git is known, citation, license, everything is known, except the malicious file, which I added recently. If I click on a directory or a file, I can get some information. I can get the type of SWHID. Here, setup.py is a content. It's a code file. I can get a SWHID. I can get potential origin. One origin. It's a Debian package here. It may not be the perfect origin of the where the code has started, but you get one origin. We are working on that, and you get some release information about that. If you click on the malicious file on the other end, you also get a SWHID, because I can compute, as the SWHID is intrinsic, you can compute that on every kind of file, but it's not known. And no provenance information was found. Obviously, it's not known. It can help you to answer to a lot of questions, knowing that the code is known by the software heritage or not. It can tell you if you are using some open source code, for instance. Maybe you have a private repository and you do not want it to depend on open source code. So run the scanner inside it and get all the SWHID of your content, and get information that maybe you are relying on dependent of some open source code that you do not know. You can also know if one of your open source dependencies is altered. Maybe you have a copy of one dependency inside your own code, but maybe someone at some point have I don't know if it's a supply chain attacks, maybe an error, a mistake, or a supply chain a malicious supply chain attacks, and your dependency become not known by the software heritage because it's modified. It's not what you think you have because there is a small modification somewhere. It can also ask, is my private code known on the internet? Maybe you have a private repository, and I don't know. Maybe it was copied somewhere on a GitHub repository, and you do not know that, and you get information that your code is known by the software heritage. If it's a private code, something is strange. And it can also give you the information about your dependency, how are they archived for long-term guaranteed access. So if you get the SWHID of your dependency and you know that this code is archived, you know that you can rely on the software heritage to get back the code at some point if something disastrous happens. Another usage of the SWHID are for the complete corresponding source compliance issue. If your code or you are distributing software using the GPL license, it requires that you provide the complete corresponding source. All the sources that are used during the build process to build the software. You can put that on a Tarball or on a GitHub repository of your own organization and put the link of that to that and get some sort of compliance. But the potential story is that you make these Tarballs at release time and you put the URLs of these Tarballs in the user manual. At some point, there may be a reorganization. Maybe the company or your organization is merging with another one, maybe it's changing its name, and then maybe it's changing its own domain name, and then you get an error on the complete corresponding source compliance URL. You are out of compliance. Another approach that we propose, and we believe it's a better approach, is still to prepare your tables for your complete corresponding source code, and then you can deposit it to the software heritage. You get a SWHID back, or you can also compute the SWHID yourself if you want, and then you can include the SWHID inside the user manual so that the code is still available for everyone and still findable at the software heritage for everyone. Another use case, here it's more an hypothesis. I don't know if you can do that right now, but it's about those SBOMs, software bill of materials. For instance, in Cyclone DX, you have a declaration section, and you have to put some information about the package or the dependency, the name, the URL, the version, and so on. All those information can be sorted out with the SWHID. You can replace most of this information with the SWHID. It will be a lot more precise. It will not depend on an external organization to give you a name, on human to give you a version, and maybe this version will disappear, will change at the time. Someone can make a new release with the same version name, for instance, and you will get some trouble. With the SWHID, you are really declaring that you rely on this specific code. You can also put that in the vulnerability section, for instance. Some entries can be also sorted out with the SWHID. You can replace that you are affected by this package issue, for instance, and telling, okay, it starts at this SWHID, and stop at this SWHID, and so on, or this error, and so on. And it can also be used in SPDX format. You can see in red a lot of information that can be replaced, or maybe you can use the SWHID with that to get a really precise information about your dependency. In fact, you are already almost already even starting to compute the SWHID, because if you compute the MD5 of file, maybe you can just put the SWHID. The SWHID use the SHA-1. It's a different hashing algorithm, but it's as good as, or even better than MD5. And you can put the SWHID to express that, okay, this is the code I'm depending on. And after that, if you add the SWHID, you can retrieve the code back from a SWHID. For instance, I built this software heritage URL where I ask for this specific SWHID, so SWH1 content, and then the ID. I put also some context information, but in fact, this context information here is not that important. And I get the code back from Software Heritage if it disappears. And it's a repository that I know, I'm the author, and it has disappeared from Bitbucket because it was on Mercurial at this point. If your code is not archived, maybe it's closed to it, maybe not yet archived, maybe you have not yet contacted us to archive it, but you still need to reference it. For instance, for compliance, for audit, for anything. You cannot obviously retrieve it from the software heritage because we do not have it, but you can still refer to it with its SWHID. You can compute locally the SWHID of what you want to reference. You can link to this reference or use this reference as a link to your reference. It's very precise, and maybe after that, you want to make it archived by the software heritage. Some incoming features that we are working on at the software heritage, which can be interesting for the SWHID also. The first one is about AI compliance. We are working on a big project to allow people to build some data set for AI using the Software Heritage Archive. So the pitch will be, please, Software Heritage, give me 500K files in Python, Golang, C++, updated in the last 3 years with no known vulnerability, used in the field of astrophysics in this pool of license, for instance. And what we want people who will use this dataset is to describe the dataset using the list of the SWHID that they used during the training. The list of the SWHID will be a small dataset which enables them to describe very precisely what they used during the training. Another project that we are working on is about security, and we are building a mapping of all the vulnerabilities on the CVE to the software heritage known SWHID and to enable you to detect if you rely on vulnerable code. Sorry, excuse me. The idea is that we will take all the vulnerabilities, the CVE, that are in databases, and we will try to detect the introducing commit and map it to a SWHID inside the software heritage, the fixing commit and map it to another SWHID. Since the software heritage has a long and broad vision of everything that happens in the open source world, we can say that all the commits beyond that are vulnerable. And maybe you have copied some code that comes with the vulnerabilities, and we will be sorry, I'm a bit sick, to tell you that, okay, this code on this SWHID may be vulnerable. We are also running a large-scale license detection on the software heritage known SWHID to detect that this particular SWHID is in this kind of license. It's all the metadata that we need for the AI project that I mentioned, but it's really interesting even if you only have the SWHID on your side. We are also working on some new SWHID computation tool Today, the way to compute the SWHID rely on software heritage code. It's in GPL, so it's kind of difficult to integrate it inside your own code. Maybe you need a more open license. So it's not decided yet, but it will be something like MIT or BSD. It's also important in the ISO standardization process that an implementation of the SWID computation is really open. And it also will be easier to use. For the moment, the SWID computation tool internal to the software heritage is kind of complicated to use. There are some defaults that are like a foot gun in your foot. You may not get the SWHID that we compute because we do not have the same defaults. We also want to work on improved provenance detection so that when you have a SWHID, you can get the information that this SWHID is in this list of projects, but you want the most important or maybe the oldest one about containing this SWHID. And for the moment, you only get one among all the potential origins. So we have to work on to improve the provenance detection. So you can help. The idea for you would be to embrace the SWHID, compute the SWHID of everything that you can. You can help us or develop tooling that you need to compute the SWHID of your project, to store reliably the SWHID of the project, to update your SBOM with the SWHID, for instance. You can also participate in the governance. As I mentioned, we build the SWHID inside the software heritage, but now it's independent from the software heritage. A lot of people of the software heritage are part of the governance, and we want to be as open as possible, and we want people from outside of the software heritage to come to participate to the governance of the SWHID. And you can help us with some current functionalities, maybe just help us to continue archiving the software on everything at the software heritage, or to develop a lot of functionalities around the SWHID. So I want to thank you and give you a few pointers. So if you want information about the SWHID, the normalization process, the governance, and everything, go to swhid.org. The site, I don't know if it's already online, but we are rebuilding it to be a bit nicer to use, maybe tomorrow or next week, but we are working on the site to be more comfortable for you. Or you can go to the softwareheritage.org if you want information about the software heritage and how we build the SWHID, or to archive the softwareheritage.org if you want to see the archive, or GitLab if you want to contribute to the code or see the code. And if you want to contact me, you have my email. Thank you very much.
Thank you, Thomas. We do have a few questions on the Q&A panel. Can you see the questions, or do you want me to read it out?
As you prefer.
I can also unmute the people who typed in the question. Let me see. The first one, oh, I don't see that person. Okay, so first there's a question, does it select to store only the source code, or do you include documentation that may be available in the repositories, for example, user manual and release notes and etc.?
Okay. For the moment, it depends on what you are speaking about. If you are speaking about the SWHID, you can compute the SWHID of almost everything, as long as it's file. In fact, you can get a SWHID of the file. It does not have to be source code. If you speak about the software heritage by itself, on the archiving process, we archive everything and it's a strategy that we have, that we do not want to select what we archive. We archive everything that we can find, but the only constraint that we have is that we do not archive file bigger than 100 megabytes, because it's in general not code. If it's 100 megabytes of code, it's certainly not good code or human crafted code, and we do not have the capacity to store it reliably. So we work mostly on source code, but in fact we use repository. If you have markdown or documentation or binary file inside the repository, we will archive it as long as it's less than 100 megabytes.
Great. There's another question from Henrik. Henrik, I'm gonna allow you to talk, so you can just unmute and maybe ask your question.
Yeah, hi everyone. I was wondering if the software hash ID is only taking into account the contents of the file that you're looking at, or whether it also looks at the metadata, especially because you said that there were different configs that you can use. Is the kind of config that you use to create a software hash ID encoded in the ID somehow, so you can make sure that you get recreatable results? And what does it look at, and what can you change about the config?
Yes. No, there is no information external to the file inside the SWHID of a given file. You just compute the hash of the file, and then you get the SWHID. If you have external metadata, they will not be stored inside the SWHID, and we do not use some parameters to compute the SWHID. In fact, when I told you that there are some parameters to compute to the SWHID computation tool, is not about the computation. It's mostly about which files to consider. For instance, if you have a Git repository, there is a hidden folder .git where Git store everything about the repository, and you do not want, in general, to include that in the SWHID configuration, in the SWHID of the revision computation, because it's not that interesting for the source code. But if you do not use good parameters, maybe they will get included and you will get some different SWHID than what you would expect. Another difficulty with those parameters is about Git submodule, for instance. Maybe you want to include them, or maybe you do not want. Or about large file storage handling in Git, for instance. Maybe you want to include that, or maybe not. But it's not about the computation of the SWHID of one given file by itself. It's about the SWHID of a repository, mostly, on which file do you want to include inside.
Okay, thank you very much.
Great. We have a question from Christian. I'm gonna allow you to talk, and you can unmute and ask your question directly.
Hello?
Yes,
Hello.
we can hear you.
Okay. Yeah. I have a question. If I want to use SWHID, or if I want to compute a hash code from my software, and this is
Yeah.
not yet archived, how can I get the tools for this?
Yes. For the moment, you have different solutions. You can find those at the website swhid.org. There are some implementation, mostly academic implementation, and we are working on a easier tool that you can run on everything and not depending on a lot of source code from the software heritage. Or you have the Python package from the software heritage to compute the SWHID. Sorry, I do not know exactly the name of the package. It's a good remark. I will put that in the slide when I share it with me and you after that.
Okay. Yeah. Thank you very much.
But you'll get the information on swhid.org.
Great. I notice Augustine, you're typing on chat, but you're only typing to host and panelists. You need to change to everyone if you want everyone to see it. Okay. And also, Wendy, you have a question. Do you want to just come off mute and ask directly?
Hello.
Yes, we can hear you.
Yes. Well, I think that I already have the answer. I was asking what do we need to do to help and who to contact. So I see an
Yes.
answer already. Yes.
If you want to participate inside to the governance of the SWHID by itself, you can go to SWHID.org, get the link to the organization, and ask us to join it. If you want to participate in code, maybe you can get the specification and implement, for instance, your own SWHID computation tool if you want, or you can go to the GitLab of the software heritage to help with the software that we built around the SWHID.
Right. Thank you.
Great. I think those are all the. Are there any other questions? Yeah, so yeah, Augustine, thank you for the links and the resources that you put on the chat. Hopefully everybody now can see that. Thank you. Any last words, Thomas, before we end the webinar?
No, thank you very much for your attention. Use the SWHID. It's a very particular piece of technology. It was at first very internal, but we see a lot of usage outside of the software heritage that are potential. And I really believe that it's interesting technology and that it can solve some lot of difficulties to precisely and independently link to software, for instance, or to source code.
Great. Well, thank you for giving this important overview of SWHID, and hopefully the attendees got some insightful information, and we'll distribute the slides that people can review at their leisure. Thank you again, everybody, for your time, and we'll talk online somewhere else.
Thank you. Bye.